Hello, everybody. Thanks for joining. Welcome to another episode of Dr. Elaine Ingham's Soil Food Web System webinar replay. Thanks, everybody, for joining. This is another session with Dr. Elaine Ingham, Soil Food Web System. And this is our weekly replay of the Colonomic Action Team. Everybody, I hope you're doing well, and we'll get started here in just a minute. So we are just about getting ready to get started. And those of you who are out there, thank you so much for being a part of the EAT community. This is Economic Action Team, Economic in Action, and we present Dr. Elaine Ingham with Soil Food Web System. We're going to get started here in just a minute. And once again, thank you very much for being a part of the Economic Action Team. And we're getting started here.
Yeah. Cool. Well, welcome everybody. We're doing something interesting. Elaine has been amazingly gracious with her time and precious energy. We had between Elaine said on her dashboards, he said 1,000 people showed up. I saw it was around 762 of you showed up live to that last webinar, and that was absolutely incredible. Since we had such a demand for questions, we decided to have a little Q&A session. We got about 40 minutes to get started here. And so thanks to everybody for writing in and sending us your questions. So I'm Raleigh Latham, joined by Sustainable Design Class founder Neil Spackman, and of course the one and only founder of the Soil Food Web Studies, Elaine Ingham. Thank you for joining us, Elaine. So we got a lot of questions, a lot of great questions from people. And so we're going to get started. And the way it works is if you're here and your question was sent in beforehand, we're going to answer it. If not, we might have to move on. So let's start with the first one. We got Dawn Vardy wrote in. So the question was from Dawn, I took the course and would like information on setups for brewing in large batches, as she refers to in the course. Some of the equipment I can find only sizes up to 1,000 gallons. We require much larger brewers for our farm.
So is Don actually on? Is he here to?
Oh, yeah, Don is here.
Okay, great. So when you're going up to those really large sizes, you need to get a hold of individuals, companies that actually do make those really large size brewers. So for example, with Nature Solutions, if you talk to James Eddington at the business, he can help you with tracking down, figuring out how much, what you want, how often, and what's really feasible. I do tend to take the attitude that it's way easier to deal with the smaller size brewers. So getting 20 1,000 gallon brewers or getting 5,000 gallon brewers. Those are a lot more readily available pre-made on the market. Typically, if you're going to make a 20,000 gallon brewer, you're going to have the people come out and build it on your property. But like James Eddington sells stainless steel brewers. He knows what needs to go into them. He knows how they're built, and so he could certainly answer those questions for you. So do we want to ask Don if he has any additional feedback for that?
Don, if you're there, give us a little, you can give us a follow-up question if you have anything. Okay, Don says, I have a 20,000 gallon cone tank, just need the air system.
Okay, definitely talk to James Eddington or Mike Lewis. He has a company called Synergy, and also here in California, in Santa Rosa, California. Either one of them, I'm pretty sure, could help you with the right size, air pump. And also, you want to think about how are you going to hold your compost. You've got to either have one really big bag, which is not going to work too well. You'll have to put an air sparger, a pipe with holes in it, into that air bag, or you're going to want to use a lot of smaller baskets that the compost goes into, and you got to make certain that that aeration occurs in that system. It takes quite a few hours to get 20,000 gallons of water to start moving adequately through the system, and then you put your compost in, so you're getting extraction instead of compaction in those bags. So a couple of further questions that you're going to have to work with those guys to figure out the answer. Okay, so go on to the next question.
Thank you, Don. Okay, so next question is from Sandy. I might have typed your name in wrong, so if you're not actually Sandy and this is your question, let me know in the question box and we'll get to it. Otherwise, we'll move on to some pasture management questions. So this is from Pam Davis. Pam, are you there? Yes, Pam, you're there. Okay, so Pam's question is, I would like to add compost to improve the pasture forage on 2 small ranches that are currently overgrazed and have poor forage. I'd like to know how to determine what kind of compost to add, promote better plant growth on both the ranch land, and how to time compost addition in relationship to seeding. Can you recommend how to choose a compost and compost tea, or can you recommend a consultant who can help figure it out?
Well, what you want to do is first test your soil and find out what biology is there. And so either you learn to use the microscope, you take the online classes and you learn to use the microscope so you can do that yourself, or you send your samples into one of the advisors who can do the microscope work, or you send it into one of the labs. And so if you're in the US, send it into us here at Environment Celebration Institute, because we've got a lab on farm, or we'll find a close by advisor for you. I actually prefer doing that. So the time between you taking the sample and the sample gets to the person who's going to look at it, and then the speed at which the answer comes back to you should be just a couple days. So we want to set up that sort of interaction, so you find out as rapidly as possible what's missing in your soil, and therefore what you have to have in your compost. And then that helps you know which kind of compost. If you start making your own compost, we do a lot of work with small piles so that you can select for the indigenous local species and get things that are already attuned to your weather conditions, rather than going far afield and bringing in something that maybe isn't the right set of microorganisms for your crop, for your soil, for your conditions. So the advisor will help you search out and find a compost. If you don't want to buy any, where is there somebody locally making a good compost? And some parts of the country, quite a few places to go to get the really good compost that are exactly what you need for your land. Other parts of the country, a little spotty, and you may have to get something from a little further away. So the consultants that we work with are, as soon as we've got our website revamped and it goes up, you'll be able to see the whole list of consultants and where they are. Right now, the way to do this would be just to email info@environmentcelebration.com and say, it sounds like you need an advisor, a consultant, and you would like to know who's closest to you, who can you work with. And so we'll answer that. You do need to tell us where you're located so that we can figure out who's the closest and the same kind of crop. Different advisors have focused in and work specifically with different kinds of crops. We have growers that work on corn, soybean, sorghum rotations in the Midwest of the United States, bananas, or apples, cherries up in the Pacific Northwest, or lawns and gardens in many, many different parts of the country. We have advisors who are in New Mexico. So let us know where you're located and what kind of crop you're growing so that we can hook you up with somebody that is going to be able to help you to to the best. Okay?
Thanks for your question, Pam. All right, next question is from Jonathan Souter. He's here and he says, what are the immediate practical steps for someone who runs a pastured animal operation to immediately implement the soil life approach? Would they, 1, test pasture soil for biology, 2, find and test compost for appropriate biology, 3, spread good biology, and 4, retest the pasture? Is it really that simple, or did I miss something?
It's really pretty much that simple. You want to test the pasture to see what's the biology that there, so you learn what's not balanced correctly in your soil food web. You know, too many bacteria, too many fungi, not enough fungi, protozoa, not the right kinds of protozoa, you know, nematodes. Do you have the full complement of bacterial feeders and fungal feeders and predatory nematodes? No root feeders. So we want to figure that one out. And then find or make composts that will have the appropriate biology in it, and we help you a lot with that step. And then when you're spreading that biology, we want to know some things about your pasture or ag field or forest or orchard, whatever you're trying to grow. Where are the compaction layers in that soil? Compaction layers mean that oxygen cannot move through that. Water cannot move through that compaction layer. Your roots can't grow through there. And your roots are supposed to be going down quite some distance, but if they're cut off and they can't grow, then you're kind of stuck. Your plants are going to put their roots out sideways, and they're all competing with each other in this top little 2-3 inches of soil. So we want to find out where those compaction layers are. You take a penetrometer, which is a just kind of fancy name for a metal bar that you are going to be pushing it into the soil, but on the top of that metal bar you put a pressure gauge. So the pressure gauge, the actual pressure plate, is right against that metal bar that you're going to be pushing down into the ground. And so you push on the gauge, and as you're pushing, you can read the amount of pressure you've got to be pressing down with, in order to move that metal bar through the soil. We know that if you hit 150 psi, work that was done at Penn State University on this some number of years ago, if you're over 150 psi, pounds per square inch, most plants cannot push their roots through a soil that's compacted to that amount or more. If you are growing things like, you know, different beets or different tap-rooted plants, those tap roots can sometimes push their way through soil that is compacted up to 300 psi. But according to those papers from the folks at Penn State, there is no plant that can push its root system through a soil that's compacted more than 300 pounds per square inch. Now, plants will find their ways to cracks and crevices to try to get their roots to move through them, but a compaction layer is usually a complete layer. There aren't any cracks and crevices in it unless you get out there with your keyline plow and open up those things. So we want you to test for compaction using that penetrometer, and remember that as water changes, you'll have less compaction layers that you can actually measure when your soil is nice and wet and has a lot of moisture in it. As your soil dries down into the late summer period, you will find every single compaction layer in your soil, because as those clays close up, as they collapse one on top of another, you'll pick up more compaction layers, and it's important to know about those. You won't find out about them when your soil is really moist. So we want to know about all of those, and then we need to get those broken up as rapidly as possible. So do we need to till? Are we going to take your compost and for the one last time ever in this growing field, you're going to go out there and you're actually going to till the compost in to as deep as you can? You're going to be slicing and dicing some of the fungi and squishing the protozoa and the good guy nematodes. They're not real happy with that treatment, but at least you're going to have somebody surviving and getting down to that depth where you can reach with your tillage equipment, so preferably something like a keyline plow. You may know them more as yeoman plows, to make certain that all that biology is getting as deep as we can, so that we break up all those compaction layers long before the root systems of your plants are going to get down there. So after that, after the compost goes in, either in the fall or maybe again in the spring, if you recompact and things really don't get built through that wintertime system, we will put more compost back into the system in the springtime. And then typically 3 applications of compost extract or compost tea to the soil surface and to the foliar, the above ground surface. Because in that first growing season, you're still getting the biology balanced correctly in your soil. And you may not have all the right microorganisms in that soil, or all these cute little soil critters wandering around in there, which crawl up along the stems of your plants and bring that inoculum of all that really good biology out to your leaves, all the way up to the top of that Douglas fir tree at 200 feet, or that redwood that's 350 feet. They'll bring this biology all the way up there. Plus, all the flying insects that land on your ground and carry the inoculum wherever they land, the birds that do that, the lizards that run up your trunks, whatever your local creatures are. And so we want to understand that whole system so we can gauge how rapidly this conversion should occur. And during that time period, we should be retesting your pasture, retesting your agricultural fields to see if the biology has gotten to the point where you're good to go. You're not going to have the weeds. You're not going to have the water problems. We're going to reduce water use. We're going to not have the pests and diseases, and we're going to increase yields. So it is that simple until you get down into the gory details. And that's where it can get to be a bit, how do we get those organisms into the system? Think about whether you have a lot of residues from toxic chemicals. How long have these toxic chemicals been applied, and which ones are they? If you've had lots of Roundup applied out in your field, we've got to do some special things to try to get rid of those Roundup residues and free the nutrients that Roundup has tied up in the soil. We're going to have some fusarium problems. So you need to know a history on your soil so we make sure that this is done as rapidly as possible.
All right.
Okay.
Thank you for the question, Jonathan. Now moving on to Alan for some suppressing weeds and increasing succession questions. So Alan asks, wait, let's see if Alan's there. Yeah, Alan Bainbridge, he says, we are in the north of New Zealand and we have a particularly aggressive grass called kikuyu. Ooh, I hate that grass. As I understand it, only the male version of the grass was brought from South Africa, so it does not produce seed, but reproduces rapidly from its rhizomes. Originally imported for its drought resistance, but its root exudates deter competition and makes it difficult to establish fruit trees. Any suggestion on how to use biology to deter this grass?
So there's kind of inherent in this a little bit of exactly what do you want to do. If you just want to get rid of the allelopathic effect from the grass, and you don't want to get rid of the grass, that's kind of one thing, and that's perhaps a little bit easier than if you really want to get rid of the kikuyu and get other grasses back in there. So if you just want to get rid of the allelopathic compounds that the kikuyu is producing so that it's not deterring the fruit trees, you want to get around those fruit trees very, very fungal, just as fast as you possibly can. And that's going to mean some injection into the soil around that fruit tree. I'm assuming the fruit trees are already in the system. Now, if you're planting the fruit trees in the next growing season, way easier because you can put all the proper compost with all the proper fungal dominance in the planting hole, make sure it's out far enough that the kikuyu are, out in the wilds and not going to be bothering your tree. But let's say you're starting with an already planted tree. You're going to want to get rid of the kikuyo in that area around the drip line into the stem of the plant, exit it. You might have to actually, take a layer of soil off the top, so you try to get rid of the weeds, and then start injecting into that area a really good, really fungal dominated compost. You want to then be feeding those organisms in the soil so that even if the kikuyu starts trying to spread back in, we'll maintain that fungal dominance and prevent that plant from being able to move back into the system. We can just apply foods that would attack and consume all of the exudates, all of the allelopathic materials coming from the root systems of the kikuyu. So you're not going to have that detrimental effect on the plant. So you can have this kind of leave the system in peace and harmony, except you're going to be out there putting on organisms and foods for the organisms that will consume the allelopathic products. And so there, you just remove that. You have the deterrence that you're asking for. Or you actually go after the grass and remove it completely. So hopefully you can let that system exist without this constant intervention. I don't know about you, but I'm just not thrilled about every month I'm going to have to go out and put on another application of these foods and some biology to deter the allelopathic effect. I want to get rid of it, so I might only have to go out there once a year and check and make sure my biology is still balanced the way it's supposed to be and say, yes, it is, great, we don't have to do anything. I'm a lazy farmer. I would rather sit back and drink my beer on the front porch and not have to be out there driving around and doing things. So either choice you could have. And a lot of people will mistake an allelopathic product being made by a plant. They'll call it allelopathy, when in fact it's just that this plant is putting out some exudates that really select for its own biology and prevents any other root system from growing into its space. Alfalfa can be like that, or lucerne can be like that, where it puts out foods that are specific for its own biology and nothing else can really grow in here. And you need to deal with that by making certain you put back in the full food web instead of letting just that very specialized food web for that particular plant. You start to see decreases in production with lucerne, with alfalfa, if you don't deal with that problem. Okay.
All right, thank you so much, Alan. Now, next question comes from Carl. Carl, are you here? Let's check. Let's check if Carl is here.
I'm not
Carl
seeing
is not
Carl.
here. What was that, Neil?
Said I'm not seeing Carl on the list.
Alas, Carl's not here. Sorry, Carl. So next question comes from Danielle. Danielle asks, hello, Elaine. Wait, let's see if Danielle is here.
You're on that name.
Yeah, that's Dan. Yeah, I'm sorry if you're there and I'm slaughtering your name. Okay, it looks like you are. Danielle isn't there. Why don't we move on to Katie? Katie had a question about the course and consultants. So she says, the course is a huge investment in time and money, and therefore I would like to understand better how the course will lead to an income stream. I'm located in the UK, and earth science professionals here are nearly always relevant degree educated and hold chartered memberships fall in relevant experience in CPD. How does this course compare, please? Thanks for the question, Katie.
When you're going for the certification as an advisor, soil food web advisor, soil life consultant, what we ask is that you first take the 4 courses: the life in the soil course, compost tea and extracts, and then the microscope. And of course we assume that you're going to buy a microscope when you're going to take the microscope class, So while I'm doing the demonstrations in the class of how to use your microscope and what all the different organisms look like, you're actually sitting there on the microscope and twiddling with the knobs and finding your own creatures in the soil. So that's the first expectation. We expect that you will have on the quizzes that go along with each one of the lectures, which of course helps you gauge whether you understood that section. And of course, it's going to be open book for the quiz. You can use all kinds of other. You can use the transcripts that come with the lectures. So even though you can't go back and watch me talk in the lecture, you got the transcript. So it's real easy to, if you paid the least amount of attention, it's pretty easy to get 90% or better on those quizzes. I do expect, I always, being an old professor, I want you to think about this information and not just regurgitate it, not just be able to flip to the place in the transcript to find the answer. So there's places where you have to actually think and put together fact one and fact two and come up with a logical outcome. Not really difficult, but you do have to pay attention, and you got to think a little bit about what it means when this happens and that happens, and oh, of course, there's the right answer, not a problem. So we're expecting 90% completion or correct answers on all of those quizzes. And then you'll be invited to come on board as a Soil Food Web trainee. What we ask you to do then is pick a place where you want to take the dirt that doesn't have the right biology in it and convert it back into soil that does have the right biology. And in the process, demonstrate that here's the area that you were starting with that's in dire straits. It's just dirt. You probably have to do conventional agriculture to make that plant grow, and then show that you know how to convert that dirt back into soil. So now this plant grows and you get higher yields, less water, no weeds, all of these indicators that you know what you're doing. You can actually do this yourself. So as part of that process, we ask that you make a compost pile. You start with a standard recipe and you notice what didn't work so well. The temperatures didn't get high enough long enough. It went very, very anaerobic. Any one of the problems that can happen if you're not actually making real compost. You're not getting the microorganisms to grow in that pile. So you learn from that first pile, and you change your recipe, you change your management practices, and you start the second pile. And now almost always that second pile is going to be really close to exactly what you want to see. And then you fine-tune your third recipe, you make that third compost pile, and now everything comes out really, really well. We have you working with an advisor, so if you have any questions, you can ask. If you ask your advisor a question that they don't know how to answer, then your advisor can come back to me, and hopefully I'll have the answer to it, although I don't know everything. So yeah, there's always more to learn. So with your third compost pile, you've got the sets of organisms that you need to fix the problems in the soil. So while you were doing that composting, you would have wanted to be looking at the soil that you want to convert from dirt, looking at the soil, looking at the dirt that you want to convert into soil. What are the needed organisms? So you start designing that compost pile to make certain that you're getting large numbers of those organisms that are missing in your dirt. So now you're going to make an extract. Well, with your compost, you could, if it's the right time of year, you could go out into your agricultural field or wherever your project is and start to put that biology into the system and start improving that system. So then you maybe make an extract, so we want you to do 3 extracts so you can improve each time, so you get real good extract, be applying it. And then you're going to make a tea. If you have foliar diseases and problems, you need to learn how to make a compost tea and put it out there, see what happens. Is it effective at dealing with any of the problems that you've got? So then at the end of the growing season, you should be able to document, did you convert that dirt back into soil? Yes or no? Here's the microbiological work. Here's the proof with the microscope work that you've been doing. And then the other markers of success, increases in yields, flavor of the fruit, nutrients in the fruit, all these, reduction in water use, weed problems, all of those you should be able to document have improved. So when you finish that project, now you've got to write it up, because that goes on our website, and we have many, many people arriving on our website every day looking for all kinds of information. Most of the time they're looking for advisors. Who's closest to me? Who can help me? Are they a mile down the road, or are they 20 miles, or are they the next country over? Looking for advisors to help them do these things. And so that's how you, as an advisor, very often will pick up clients. As an advisor, you'll probably want to be going to some of the local grower groups and attending their meetings and starting to present. As you have data, and we require then that you make the data, produce that data. So now you've got a story, you've got information to give out to everybody. Look what I did, and here's the data showing exactly why this conversion happened. So it's almost a given that you're gonna have developed several good clients by the time you finish your project. Then when we have people call us or get hold of us and say, who's the closest advisor? We're going to be sending people to you. Hey, Katie, or whoever. Here's a person that in your vicinity that is looking for an advisor. Do you think you could take them on? Do you have enough time? And that's the biggest problem for our advisors right now, is almost all of them are completely booked up. They're making all the money they require. They're buying the bigger truck. They're buying mobile laboratories so they can go around to all of their clients that are spread all across the western part of the United States. So they in their lab travel through the summer. So that, I hope, answers that question for you.
All right, thanks so much for the question, Katie. Oh, and just a reminder to folks, if you look in the chat box below, there's a link to Elaine's offer for Life in the Soils classes now. This is super important. This is the last day that she's allowing us to have this really fantastic offer. Neil and I are going through at the moment. It's mind-blowing. Every single session, you're going to learn more about biology than you will ever at college. My mind has been blown. I think it's absolutely amazing. Let me just show that on the screen real quick, and then we can get back to some more questions. So yeah, check it out. Look at the chat box. I'm sure most of you have got this offer in your inbox. But yeah, last day to buy Life in the Soils classes at the 50% off discount. Do it. It's amazing. You will absolutely not regret it. And plus, if you don't like it, you can get your money back, which is awesome.
Yep.
So next question. Let's get back to it. Next question comes. This is some specific land questions. We've got a few more to go through. I'm just going to paraphrase this. So this is from he's here right now. This is from Ralph Drachkorn. Hey, Ralph. So he says he's in Texas Hill Country. He's dealing with many generations of degraded land, sheep, plows, 10 years of letting it rest, and it's not working. Still nothing growing but weeds, and years of trying to start native grasses, and it's not working. He says, where do I start to offer a solution when 3 generations of experience with traditional methods have failed? And anyone says that any other way is flat out impossible. How do you approach a situation like that?
The first thing we want to do is go out and look at what biology you have there. My suspicion with your description of what's going on, where it's nothing but a weed field, and years of trying to start the native grasses and wildflowers have failed. The reason they failed is because when that seed germinates and the roots go down into the soil, they're expecting to find this natural, normal nutrient cycling process with the bacteria, fungi, protozoa, and nematodes. And with our native grasses, especially in Texas, when we're looking at, like black grandma, some of the highly productive big and little blue stems, they have to have fungal dominated soil. And if you go out and look in your soil in your dirt right now, probably all you would find would be massive numbers of bacteria, and probably most of them would be anaerobic, disease-causing, not the good guys, not going to be helping your plants grow at all, and probably, in fact, competing with them. So we got to start that shift. Here we go with the compost again. We want you to find some of the people in Texas that make really good compost. So, just off the top of my head, the Texas Worm Composting Ranch up near Fort Worth makes excellent compost. Quite often, I'm trying to think of their names and I'm spacing it. It's Betsy Ross's operation. She's the one who started it out in Austin. It's just not going to come to me. So there are quite a number of good places that make good compost in Texas, and if you can't find them, have them show you the microbiological assessment. Don't buy compost if they won't do a microbiological assessment, because there's a reason they won't do it, because they know that you wouldn't buy it if you can see that there aren't any good biology. If a compost just contains massive numbers of bacteria, well, that's what's already in your soil. And why add insult to injury? So you want to find some really good compost, and now think about what's the best way to get it out. Lots and lots of rangeland, probably not going to be the way to go out and till all that rangeland. Kind of scary. So instead, what we'll often do is turn that compost into a compost tea and soak your bales of hay. Like in the winter when you go out to put hay out for your animals to eat in that winter time period, we want to soak that bale with hay, a bale of hay, with that really good set of microorganisms. Put it out, the animals eat it, it improves their digestive system. All of a sudden their rumen starts working better. And every time they poop, out the other end is going some of these really beneficial organisms, and then their hooves spread that biology all through the pasture. Everywhere they walk for the next 3 days, they are going to be spreading this really good biology. Then in the springtime, go in and overseed with seeds that have been soaked for about 5, 10, no more than 15 minutes in a really good compost tea with all of the organisms, making sure you've got the mycorrhizal fungi in there as well. And then you go and seed, so that as soon as that seed germinates and that root system comes out, all that really great biology is already on that root system. And so you don't have that situation where it just doesn't grow, it can't succeed, it's struggling, and the weeds overtake it. So as we can start converting that dirt back into a soil that has the proper balance of fungi and bacteria, the weeds can't compete, because the source of nitrogen is completely wrong for the weeds. And it's now finally, for the first time in how many years, finally the form of nitrogen is exactly what those native plants require. So let's have you go through that process, hook you up with an existing advisor and have you go through this process of converting your dirt back into soil and get that rangeland back to what it should be, highly productive grassland where you can run a set of cows and they are going to be the healthiest guys you've ever seen. So Hope that answers that question.
All right, thanks, Ralph. Hope that answered question well. Ooh, this is tough. We've only got 3 more minutes. Wayne Dorban has an economic action team session on water at 4:45. So hopefully, I think we can get to one more question. Elaine,
Okay.
you reckon we can do that? Okay, so let's see if Elizabeth is here. She is not. So is Saneeth here?
Yep, she's here.
Okay, Saneeth is here. Saneeth asked, I believe she mentions that the best time to start inoculation is autumn in the U.S. What would be the best time to get started with inoculation in a tropical climate?
Typically right at the end of the dry season, just before the rainy season's going to start. So get those seeds out there, get the compost out there, till the compost in if it's right the first time that you're trying to break up all those compaction layers. Otherwise, compost in that right before the rains start to happen, and then all through that rainy period, your organisms are going to just grow like crazy and do all these positive things for your plants. Okay.
Oh, wow. Well, there we go. That was nice and quick. See, is Felicia here? She is not. So next question from Manos. Is Manos here? He's coming from Greece. Okay.
Pretty late in Greece.
Yeah, let's see if Wendy's here. Okay, Wendy. Oh, wrong Wendy. We got Wendy Campbell on the line, but not Wendy Aletha. So, alas, sorry about that, Wendy Aletha. All right, so I guess last question before we get on out of here. So a few of you typed in your questions here. I'm going to go to one of the early ones. Here's one from Janet Henderson. She asks, are you there, Janet? Yeah, okay. She asks, what is the best way to remediate soil that has grown GMO corn and soy on it? Is it worse than compacted clay soil?
You have some genetic material in that soil now that people are showing that it can move into the root system and start altering non-GMO crops. So what we want to make certain is that your soil has all of this good food web in it, so those GMO genetic sequences will be decomposed and gotten rid of. When I was a chief scientist at Rodale, we did one round of compost where we knew we had GMO residues in there. We purposely made sure that we put the GMO residues in there. We know how much. We could do the, what was the concentration of the DNA sequences at the beginning of the composting process. And then we composted correctly with fully aerobic, getting the temperatures up, turning right on time, getting this whole food web up and functioning. And at the end of the composting, when the temperatures came back down to ambient conditions, we tested again for those genetically engineered sequences. None of them could be found. They were gone. So if we can get that biology back into your soil where GMO crops have been grown, we can get these really beneficial aerobic organisms to completely decompose those DNA sequences, and you no longer have to worry about having that leftover surprise little factor of the GMO DNA sequences getting into your current crop. So there's a way we can solve that problem.
All right, that was a great question to end on, because glyphosate farms are a freaky business. So thank you so much, Elaine, for joining us. We got to get going now, but this is not going to be the last time that we're going to have Elaine on. She's just a wellstream of just priceless knowledge on the soil, so we'll be stoked to bring her back on if she wants to be here.
I would love to come. I've only been working on this for like 45 years, and it's something that everybody needs to understand. Growing plants is so much easier than you ever suspected, but we have to get the biology in the soil to help you.
All right. Good
All right,
words
folks,
to
we're
send
done.
off
Jump
on.
off.
All right, you got. Oh, one last thing. We'll send the replay out to everybody. Have a fantastic day, and if you can, sign up for the classes. Start learning about soil because it will be one of the best things you ever do in your life. I appreciate you tuning in, and tune in for more Sustainable Design Masterclass sessions. Have a great day, folks.